Hello everyone, my name is Joe Scorson, channel is called Ethernet and in today's video we are on day 11. I don't know why I tried to record that intro like 4 times too. It hasn't gotten easier, and I don't know why I decided to do that, but it's day 11 of the Quant Finance Advent to Code series that I'm doing. Today we have a parallel backtester written in Python. Implementing it super simply, just with 3 different functions, and it's not an object yet. That's probably what we're going to do in the next video. But yeah, let's just stay on topic and stay with this video. We're just gonna make a parallel backtester to backtest a simple moving average strategy with different parameters and different risks and stuff like that. So instead of doing one backtest, waiting, you know what I mean? We could just do them all at the same time. Let's hop into that first. Thank you guys for all the growth on my X account. That's crazy. I wanted to get to 100 followers before the end of the year. I think I can get to 200. So thank you guys so much for that. If you guys like to actively trade, my algorithm with Lux Algo might be the thing for you. There's videos about it on my channel, backtesting it. There's a whole bunch of different information. There's a bunch of stuff on my X about it, so check that out. And I kind of want more GitHub followers, so this is my GitHub profile. Of course, all of the code for this is in this repo, and I also made a neural network from scratch in C++. So I want to make a video about this, just going over it. But of course, we're in this series right now, so no. But yeah, maybe in the beginning of the year, next year. I like C++, man. I've just been coding it a bit to prepare for something. Like coding a neural network is kind of like my first project in different languages when I learn them, because it's really just, I think it gets everything down pretty well besides file input output. But I just like coding neural networks. I can almost do it from memory. That's just something I want to have in the back pocket. You need a neural network, just give me 30 minutes. But yeah, let's hop into today's code. Not my face. Where do I want to go? Here and there, and move it. Perfect. So today all we have to do is implement functions to backtest a simple moving average cross strategy in parallel with different parameters. Save the backtest results as CSVs and get each data frame back to plot them. Simple enough. So if you guys remember, in other episodes we made this async cache. We modified our get stock data to be able to use the cache, so that way if we can cache hit something, it's basically instantaneous compared to reading a CSV or actual API connection. And we have this simple moving average cross strategy from like episode 2 or something like that. So they're all making an appearance again. And then all we have to do is this simulate function, this plot balance, this run back test, so that way we can actually get everything as a code routine. And then in our main, we just have all of our configs and stuff like that. And then, yeah. So let's go top to bottom, and let's check out the simulate backtest data function, whatever. So we're going to start off with an initial balance, a risk of a percentage of the portfolio that we're risking, a transaction cost simulation, and initial take profit and stop loss. I just initialize them to that value so we don't have any errors ever. But yeah, we have to make sure that our balance is afloat, so that way Pandas doesn't freak out. And then we just have these initial variables for our entry price, position, 1 for long, -1 for short, 0 for no position, and our position size. Copy the data frame, again, so Pandas doesn't lose it, and then set our balance function or column to be our balance. So now we can iterate through, and we could check for every condition pretty much and then handle it accordingly. So we're just going to get our signal, and then we need to check if we're in a position. So if we're in a position, we want to check what the price change is, because even if we don't exit yet, we want to update it. So we're going to see if our position is 1, check for the risk, and then we could close it out and reset these variables. Same thing but opposite, of course, for short. So that's if our position is not 0. If the signal is 1 and our position is either short or flat, we want to open a position. So our position is 1, and our position size is the risk times the balance, and over the close, that way we can see how many shares we have with 10% of our account. And then entry price is whatever price we're at. Really should say int right here, but fractional shares exist. Small detail on this. And then the opposite. The opposite for when we have a short signal and we are either long or flat. If we are long or short before any of these, we would just have to close them out, and then we would have to just re-enter our other position. So then, regardless, after all this stuff, we need to update our balance. So there it is. And then, yeah, at the end of it all, regardless of if we're in a position or not, we want to log our balance. That way we can accurately test everything. Yeah, so now in our plot balance function, we just need our data frame for each backtest. We're going to get into that. And then the title that we're going to put for it, get into that. But yeah, this is just a simple plotting function for our balance. That's the only thing we need to plot. I set it to dark mode, but you don't have to. And then we have a run backtest function. And this has our start and end dates to get stock data, has our parameters for short and long windows, has our risk and our take profit and our stop loss and our cash. So then we would just get a backtest ID different than a plot title, which we're going to get to. Get our stock data, get it for the specific ticker, add a moving average cross strategy for it, get our results, get our CSV, get our plot title, and then just plot it. And we also want to return our results. So that's pretty much all. So then once we're in our main, set our start and end date. I have it set to CrowdStrike because I already have a CSV for it, so it'll be really quick. Now we can define our configs right here. So it'll be a dictionary like this. So for every ticker that we have, for every short window, short value we have, every long value we have, all of our risk, that should be higher. Say like 5% and then 10% of the account. And then we have our take profit and our stop loss values over here. So then we could run all of our backtests in parallel. So just run our backtests with each thing. And then for every, right, because now we have all of these configs, right? We have these different dictionaries, and this is a list because we have a bunch of different parameters. So now our tasks is to run every different configuration that we could have. So for a config in backtesting configs, we have all of our tasks. And then because run backtest is an async function, it is a coroutine. It also will return, it does return this, but we have to await it. It is like running in the background pretty much. So that's why tasks is the thing going on. So we want to gather a pointer to all these tasks. We want to say like, hey, get that thing over there and like gather it up, because we want all these tasks to run as one thing, as one container pretty much. Container is not the right word because Docker exists, but as one basket, right? All these tasks are related to each other. We want it all to be wrapped in a future and scheduled in the event loop. They will not necessarily be scheduled in the same order as they are passed in. That makes total sense because, you know, it's just async stuff. It gets a little funky. And then we could just run our main. So now let's go through and we have 2 to the 1, well, 2 to the 1, 2, 3, 4, 5. So we should probably get, and just one ticker. So we're going to get like 2 to the 5 backtests. No, that sounds huge. That sounds wrong. Regardless, though, we're going to get a lot of backtests. What is 2 to the 5? And yeah, it's just going to wig out for a second. Just let it do its thing because you can see at the top, I'll get out of full screen. It's just getting a bunch. Yeah, I have no idea. I'm not going to do 2 to the 5 on the top of my head right now. I'm still tired. I'm still feeling a little. If you guys watched the order book episode last night, still a little tired, still a little out of it, but doesn't matter. We're still getting all the work done. And yeah, someone's got to save the world, right? So now all of our backtests are done. So let's start at the beginning. And so yeah, you can see how we could just go through and you could check out every backtest. That's the whole point of something like this, is that way you can go through, you can see which ones do better than others, right? We have a lot here. And so then you could pretty much see like, okay, these first ones, like I think this one is the best, right? So, and we can also see how Now the sizing is nice, right? So now risk is 10% of the account, and 10 and 50, I think that was over here. Yep, and you can see how it's the same. I'm trying to remember the spot. Yeah, you can see how it's the same back test, but different risk and stuff. So I think it's this one and that one. Yeah, you can see how that's the same performance, but just one's a bigger number than the other because we're just putting more of the account on it. But yeah, so you could go through, and obviously these positions, I mean, these points in time when we're flat, we would just not be in a position yet because we would get or our take profit or our stop loss would get hit. I don't think there's many scenarios when we would flip, right? Where like we'd be in a position and we wouldn't hit risk before we flip. But yeah, that's how to make a parallel backtesting little engine in Python. I'm going to close out all these windows, but it'll get a bit more complicated in the next video. Not much more complicated, but a little bit more dynamic, a little bit more reusable, because I'm going to make it be a class. So that way you could just say like backtester dot run backtest and give it the configs. And so that way you don't have to do, not that. So that way you don't have to do this pretty much. It'll do it for you. But you would still just have to set the configs, and then you would just have to, you just have to have it as an object. Wouldn't be very difficult if you guys want to try to do that before the next video. You would just have to put all of this in a class, have an initialize for everything that you'd need, every parameter that you would need, just have an initialize for it, and have an initialize for the configs. Have an initialize for the configs, so that way when you call this stuff, you could loop through it in this. You wouldn't have to modify much. But yeah, have an initialize for the configs. That'll have everything else that you need, and then so that way, yeah, like I said before, you guys could just kind of do this it wouldn't be much. You just have to move some stuff around and wrap it in a class with an initialize function. Try it out before the next video. Maybe it's something that you would enjoy. And I feel like I go fast when I explain this stuff. This is let me know if I go too fast ever, because I do that a lot in a lot of different things. I had a presentation in my linear algebra class the other day. I did a presentation on gauge models, and I feel like I flew through it, right? Because I wrote the paper on it and I coded one. So I coded it in TradingView, but so it was fresh. You know what I mean? It was fresh in my mind. I understood the eigen decomposition. I understood why we were doing certain things because I was versed in quant finance. So I feel like I just blew through the presentation, and I put the light bulb up. Like maybe I do that in my YouTube videos as well. Say, let me know if I ever go too fast. Like I said in the next video, we're going to wrap this in a class so that way it's a bit more portable, and we are going to put a more complicated strategy on it than just a moving average cross. I was thinking something with long memory and just, I don't know, and then probably just a machine learning model for it. And then in the future, whenever we do learn about machine learning and stuff like that, we could apply it to this, right? Because all you would need is a signal column, and you guys could use this backtest function on it, right? The only thing that would need to be consistent is the signal column in the data frame that you're going to give it already. Oh yeah, that was also something you need to do for the class, is make sure that you give it the data frame. But I don't think that'd be very hard. Regardless, I hope that you guys enjoyed this video. Hope that you guys are excited for the rest of the episodes. Hope you guys are enjoying this series. And yeah, I will catch you guys in the next one. Ciao, ciao.